Hi everyone, welcome to the channel. Today we will be starting a new chapter on LEED Green Associate exam, which is Indoor Environmental Quality. So without any further delay, let's move on to the chapter. Before that, if you guys haven't subscribed to my channel yet, please do so. In this chapter, there are 2 prerequisites and 9 credits in total, and they hold a score of 16. Now let's look on to the prerequisite environmental tobacco smoke control. And the intent of this prerequisite is to prevent or minimize exposure of building occupants, indoor surfaces and ventilation air distribution system to environmental tobacco smoke. Now let's look on to the requirements for achieving this prerequisite. One is prohibit smoking inside the building as well as outside the building except in some designated spaces, and it should be located 25 feet, that is 7.5 meters from all the entries, outside air intakes and operable windows, that is from all the openings of the building. We have to keep an 25 feet distance for this designated smoking areas, and also prohibit smoking outside the property line in space used for building business purposes. And we have to provide a signage, and it must be posted within the 10 feet, that is 3 meters of all building entrances, indicating no smoking policies. And if the requirement to prohibit smoking within the 25 feet cannot be implemented because of code, provide the documentation of this regulation. Well, there are 2 options for achieving this prerequisite. Option 1 is meet the requirements which we mentioned on the previous slide. They are like provide designated areas outside the building, and it should be 25 feet away from all entries, outdoor air intakes and operable windows, and also provide signage within the 3 meter from the entry, providing the non-smoking policy, etc. But option 2, which is compartmentalization of smoking area, here we need to prohibit smoking inside all common areas of the building. Then the prohibition must be communicated in building rental or lease agreement, and then prohibit smoking outside the building except in designated smoking area, same as option 1. Okay, and it should be located at least 25 feet, that is 7.5 meters away from all entries, outdoor air intakes and operable windows. The next prerequisite is minimum indoor air quality performance, and the intent is to contribute to the comfort and well-being of building occupants by establishing minimum standards for indoor air quality. So the requirement is to meet the requirement for both ventilation and monitoring. So for ventilation, there are 2 ventilated spaces we need to consider. One is mechanically ventilated spaces and then naturally ventilated spaces. For mechanically ventilated spaces, there are 2 options. Option 1 is ASHRAE standard 62.1 2010, and option 2 is EN standard EN 15251 2007 and EN 13779 2007. Let's look on to the option 1 for mechanically ventilated space, and it follows ASHRAE standards 62.1 2010. There are 2 parts for achieving this option. Part 1 is for mechanically ventilated spaces. Determine the minimum outdoor air intake flow for mechanical ventilation system using the ventilation rate procedure from ASHRAE 62.1 2010 or a local equivalent, whichever is more stringent. And the part 2 is meet the minimum requirement of ASHRAE standard 62.1 2010 ventilation for acceptable indoor air quality. Here also we can take ASHRAE or the local equivalent, whichever is more stringent. So for projects outside US, can refer other standards like CEN standards EN 15251 2007 and EN 13779/2007. Here this option 2 is based on these standards. Let's look on to this option 2. So for projects outside the US may instead meet the minimum outdoor air requirements of Annex B of Committee European Denormalization, that is CEN, standards EN 15251/2007, indoor environmental input parameters for design and assessment of energy performance of building, addressing indoor air quality, thermal environment, lighting and acoustics, and also meet the requirements of CEN standard EN 13779/2007, ventilation for non-residential buildings. Now let's look on to the requirements for naturally ventilated space. One is for naturally ventilated spaces, determine the minimum outdoor air openings and spaces configuration requirement using the natural ventilation procedure from the same standard, ASHRAE standard 62.1/2010, or a local equivalent, whichever is more stringent. And number 2 is confirm the natural ventilation is an effective strategy for the project by following the flow diagram in the Chartered Institution of Building Services Engineers, that is AIBSC Applications Manual M10 March 2005. Please note all these standards, and the figure is given natural ventilation in non-domestic buildings, figure 2.8, and also meet the requirements of ASHRAE standard 62.1/2010. Now let's look on to the requirements for monitoring of mechanically ventilated spaces. For both variable air volume system and constant volume system, we need to monitor the outdoor airflow movements. So for variable air volume system, provide a direct outdoor airflow measurement device capable of measuring the minimum outdoor air intake flow. And for constant volume system, balance the outdoor airflow to the design minimum outdoor airflow rate defined by ASHRAE standard 62.1/2010 or higher. Now let's look on to the requirements, monitoring requirements for the naturally ventilated spaces. So option 1 is providing a direct exhaust airflow measurement device capable of measuring the exhaust airflow. We need to measure that exhaust airflow. Then option 2 is providing an automatic indication devices on all our openings, natural ventilation openings, including windows, etc. and other openings, intended to meet the minimum opening requirements, and an alarm must indicate when any one of this opening is closed during the occupied hours, so that these occupants get notified and they can open these windows. Number 3, or option 3, is monitoring of carbon dioxide concentration within each thermal zone. So basically we have to monitor the carbon dioxide concentration, and the measurement or the monitoring must be done between 3 and 6 feet above the floor level. And also this carbon dioxide monitoring must have an audible or visual indicator or alert the building automation system if the sensed carbon dioxide concentration exceed the set point by more than 10%. So the set point is calculated using the methods in ASHRAE 62.1/2010 Appendix 6. So for almost all these standards in indoor environmental quality, we need to refer ASHRAE 62.1/2010. For residential only projects, there are some other criteria other than this carbon dioxide concentration opening requirements. So let's look on to that. Number 1, unvented combustion appliances, for example decorative logs, etc. are not allowed. Then along with the carbon dioxide, carbon monoxide monitor also must be installed on each floor of each unit. All indoor fireplaces and wood stoves must have solid glass enclosure or door that seals when closed. And next is any indoor fireplaces and wood stoves that are not closed combustion or power vented must pass a backdraft potential test to ensure that depressurization of the combustion appliances zone is less than 5 PA. So there are two more remaining points under this section, residential overlay projects. One is again deal with carbon dioxide. Spaces and water heating equipments that involve combustion must be designed and installed with a cost combustion system or with power vented exhaust, or it can be located in a detached utility building or open air facility, because again this combustion is connected with the carbon dioxide production. That way it has to be done in a sealed area. So otherwise it can be detached utility or in an open air facility, whatever works. Then next is related to radon gas. So we all know that radon is very poisonous, and it's like a slow poison. When the people like intake radon, like after years they get affected, like it can turn to lung cancer, etc. There are studies says that. So for projects in high risk areas of radon, EPA radon zones, design and construct any dwelling unit on level 1 through 4 above grades with radon resistant construction techniques. So LEED suggests to follow the techniques prescribed in EPA building radon. So the standard you can refer, or it can be a local equivalent. Basically, radon can accumulate in some places where ventilation is inadequate. Then long-term exposure, actually, as I mentioned earlier, it can increase the chance of getting lung disease, which can cause coughing and difficulty in breathing, and eventually like it can cause lung cancer. So this long-term exposure to high level of radon can be dangerous to our health, and yeah. So it is produced when uranium, thorium and radium break down in soil, rock and water. It's then released into air. Radon is odorless, tasteless and invisible. So yeah, this is all about radon. What we need to know, it's very harmful and certain, like more than the in limit, it can be again cause trouble to the human being. Now let's start learning the credits in this category, indoor environmental quality. The first credit is enhanced indoor air quality strategies. This credit actually deals with the strategies which enhance the indoor air quality. So this particular credit can get 2 points, and the intent of this credit is to promote occupants' comfort, well-being and productivity by improving indoor air quality. Option 1 is enhanced indoor air quality strategies, and it can get up to 1 point. Basically, there are 3 ventilation systems: mechanical, natural and mixed mode. So for each mechanical system, comply with the following requirements as applicable for achieving this credit. All these requirements are similar, mostly similar, and there is only some difference in each system. Let's look onto that. So first, mechanical ventilated system, entryway system is required. Interior cross contamination prevention and filtration is required. So I can explain you what is an entryway system and interior cross contamination prevention and filtration in the next slide. So for naturally ventilated spaces also entryway system can be provided. Natural ventilation design calculation can be done. For mixed mode, which is a which is a mixture, we can say like that, it's a mixture of mechanical ventilation and natural ventilation. So these requirements are almost the sum of these two. One entryway system, then interior cross contamination or prevention, filtration, natural ventilation design calculation and mixed mode design calculation. In mechanical ventilated system, naturally ventilated system and mixed mode system, we saw about entryway system. So we need to install permanent entryway system at least 10 feet, that is 3 meter long, in the primary direction of travel to capture dirt and particulates entering the building at regularly used exterior entrances. This entryway system pictures are shown in the page. So, acceptable entryway system include permanently installed grates, grills, slotted system that allow for cleaning underneath, rollout mats, and any other materials manufactured as entryway system with equivalent or better performance. And also consider one thing, maintain all on a weekly basis. Next is interior cross contamination prevention. Sufficiently exhaust each spaces where hazardous gases or chemical may be present, which can be garages, housekeeping areas, etc. using the exhaust rate determined in environmental quality prerequisite minimum indoor air quality performance or a minimum of 0.50 CFM per square foot to create a negative pressure with respect to the adjacent space when the doors to the rooms are closed. Next is filtration. Each ventilation system that supplies outdoor air to occupied spaces must have particles filter or air cleaning devices that meet one of the following filtration media requirement. One minimum efficiency reporting value of 13 or higher in accordance with ASHRAE standard 52.2 2007. Then class F7 or higher as defined by CEN standard EN 779-2002 particulate air filters for general ventilation determination of the filtration performance. Option 2 is additional enhanced indoor air quality strategies with house 1 point. For achieving this, comply with the following requirements as applicable for mechanically ventilated space, naturally ventilated space and mixed mode system. But here we need to pick only one from this criteria. For mechanically ventilated space, the options are exterior contamination prevention, increased ventilation, carbon dioxide monitoring, or additional source control and monitoring. For naturally ventilated spaces, here also we need to pick only one from the three. A. Exterior contamination prevention, the additional source control and monitoring, and or natural ventilation room by room calculation. And finally for mixed mode system, here also we need to pick only one. Exterior contamination prevention, increased ventilation, additional source control and monitoring, natural ventilation room by room calculation. So we can choose the required as applicable for situation. Well, we have covered 2 prerequisites and 1 credit in this category. Tomorrow we will start with the remaining credits. And if you guys find it helpful, please support my channel by subscribing and liking the video. So yeah, thank you.